want to give you a brief introduction to the Kelvin scale. We will use this a lot in chemistry. It's very, very common, and for a variety of reasons we actually need to use it in several of the formulas that we're going to work with this year. It's very much related to the Celsius scale, and the guy who proposed it, a guy named William Thomson in the mid-1800s, his title was Lord Kelvin, which is why it's actually called the Kelvin scale, proposed this, and what he was looking for is a scale that's based on the Celsius scale, but just starts at absolute zero or null point or infinite cold, as you see referenced in the paragraph. And by the way, the paragraph, that information you see on the screen there, is from Wikipedia. The observation that had been made for a long time, and you've probably noticed this yourself, if you take a balloon out on a cold day and look at its volume, it gets smaller. As you cool it down, as I lower the temperature, notice I'm lowering my temperature, notice what happens, my volume decreases. And so this was known about, and there was the expansion would be the opposite of this, which is given here, the expansion coefficient. As you heat it, it expands. So if we take the inverse of this and talk about the contraction of this, the question is really, at what point will this volume go all the way to zero? And it turned out they found that to be negative 273, and like pi, we can go a little farther along. You'll see some folks do negative 273.15, and that is degrees Celsius. So as they sent this temperature down farther and farther, they noticed it getting smaller, and then they extrapolated. This represents an extrapolation. They could not get this cold in the 1800s, but they extrapolated down and said, well, where would that volume go to zero? And that is the temperature on the Celsius scale. So what ends up happening is we now know that the absolute zero is approximately negative 273 degrees C, but we call that 0 Kelvin because that represents the coldest temperature, or absolute zero, that you can have. Now it turns out then that every degree you go up Kelvin, you also go up a degree Celsius. So if I go up 273 degrees Kelvin, okay, I'm at 273 K. If you go up from negative 273, go up 273 degrees, you'll be at 0 C. So notice a degree C and a degree Kelvin, they move at the same rate, it's just they start at different points. If I add 100 degrees to this, I end up at 100 degrees C, which the boiling point is the boiling point of water. If I add 100 degrees to this, I get 373. And of course that is the boiling point of water as well. So that is really the difference between these two. I always tell folks there are formulas that you can write out, a degree C plus 273 or minus 273 equals Kelvin and vice versa. You can go back and forth with this sort of thing. But what I tell folks, just basically remember this, that the Kelvin number will always be 273 greater than the Celsius. If I ever give you the Celsius temperature and ask for the Kelvin, you're going to add 273, and this is that formula I was just referencing. If I ever give you the Kelvin and ask for the Celsius, of course you're going to take the Kelvin minus 273 to get the Celsius. But rather than sitting there trying to memorize formulas like this, and I think you can get kind of confused if you worry about that sort of thing, what I would just simply do, just remember the Kelvin number will always be the higher number. If you're doing a conversion back and forth, Kelvin number should be higher, and it should be 273 higher. If you prefer to use 273.15, and you'll see a lot of people do that, that's certainly fine, but I just want you to understand where this comes from and what's the relationship.